Okay, so how do you teach an AI to be not just good at something, but to be truly, genuinely innovative? We're about to dive into a brand new algorithm that doesn't just learn one strategy. It creates what you could call a digital Cambrian explosion of them. Let's get into it.
The researchers kick things off with this really powerful analogy from the natural world. So picture a leopard, right? It's perfected its hunting technique. But then the environment changes. Maybe a new, tougher predator shows up. All of a sudden, its old strategy is totally useless. To survive, it has to adapt. It has to innovate. And that's the exact same challenge that AI faces.
So this is the fundamental question, isn't it? Can we build an AI that doesn't just get really, really good at one thing, but can invent a whole new playbook when the rules of the game change? Can it learn to adapt, just like that leopard?
To really understand the solution here, we first have to wrap our heads around the problem. You see, most AI systems, even the incredibly powerful ones we have today, have a kind of a built-in limitation when it comes to true out-of-the-box innovation. AIs are absolutely brilliant at quality. You can give them one strategy, say for a game like Go, and they will practice and refine it until they're playing at a superhuman level. But where they often get stuck is diversity. They tend to fall into a rut, unable to generate a wide range of different creative solutions. They find that one good answer and they just cling to it for dear life. So how do we fix that? Well, the researchers are proposing a new algorithm called Quality Diversity Self-Play, or QDSP for short. And it's this really brilliant combination of three powerful ideas that all work together to create an engine for pure innovation. Okay, the first idea is self-play. And honestly, this is how champions are made. An AI plays against itself, or maybe past versions of itself, over and over and over again. With every single game, it has to get just a little bit better, a little bit smarter to beat its toughest opponent, which is itself. This whole process creates this relentless arms race that just pushes for higher and higher quality. The second big idea is quality diversity. Now, think of it this way. This isn't about finding the one single fastest car. It's about designing an entire showroom full of incredible vehicles. You want the race car, sure, but you also want the rugged off-roader and the comfy luxury sedan. The goal here is to build a whole library of solutions that are not just good, but are also fundamentally different from each other. And the third ingredient provides the creative spark. Foundation models, things like GPT-4o. These models are trained on absolutely massive amounts of text and code, and they act as an intelligent search operator. They are literally the engine that dreams up new, weird, and maybe brilliant strategies for the rest of the system to go and test out. So how do these three parts come together? It's actually a really elegant loop. First, the foundation model proposes a new strategy, writing it out as actual computer code. Then, the system checks it out. Is this new strategy genuinely new? If it is, boom, it gets added to this growing library of diverse solutions. If it's kind of similar to one we already have, they compete against each other, and only the winner gets to stay. This simple cycle constantly pushes for both novelty and quality at the same time. Of course, a cool idea is one thing, but you gotta prove it works. So the researchers set up a test. They put their new QDSP algorithm to work in a classic pursuer-evader game. A simple game of tag, really, but with a fascinating strategic twist. Here's the setup. The pursuer is fast, but it's clumsy. It can't turn on a dime. The evader is slower, but it's incredibly agile. To win this game, you can't just rely on one trick. You need a whole bunch of different tactics. It's basically the perfect little sandbox for an innovation engine. So what happened when they let QDSP run loose in this environment? Well, the results were nothing short of what the researchers themselves called a Cambrian explosion of strategies. Just a sudden, massive diversification of complex and super effective solutions. The results were just staggering. I mean, look at this. The AI didn't just invent one type of solution. It independently discovered and coded strategies from completely different fields of computer science. It came up with Monte Carlo tree search, genetic algorithms, Q-learning. It was essentially rediscovering decades of human research, all by itself. But were these strategies actually any good? Well, when they pitted the AI's creations against strong policies that were designed by human experts, the AI strategies performed just as well as, or in some cases, even better than the humans. It wasn't just being creative for the sake of it. It was being incredibly effective. So it's really important to remember the goal here was never just to find the single best strategy. It was to find a whole collection of different high-performing strategies. And to measure that, the researchers used something called a QD score, which basically combines both the quality and the diversity of the solutions into a single number.
And when they compared QDSP to other approaches, the results were crystal clear. An algorithm that only focused on quality, yeah, it found one good solution, but had really low diversity. An algorithm that only focused on diversity, it found lots of weird ideas, but none of them were very good. QDSP hit that perfect sweet spot, getting the highest QD score by finding the best combination of both quality and diversity.
This is all incredibly exciting, but what does it really mean beyond just winning a computer game? Let's zoom out and take a look at the bigger picture here, because the implications, they're pretty huge.
What's truly significant about this is that it's way more than just a better game-playing AI. This is like a blueprint for an engine of automated discovery. Can you imagine applying this to accelerate innovation in fields like drug discovery or materials science? And because the strategies are written in human-readable code, we can actually understand the AI's thinking. This is a massive step towards AI that is not just powerful, but genuinely creative and adaptive.
And this leaves us with a really powerful question to think about. We've always built AI to solve the problems that we define for it. But what happens when AI starts inventing entirely new ways of solving problems? If it can reinvent huge chunks of computer science in a simple game, what happens when we point this engine of innovation at the biggest challenges we face in science and engineering? We may have just seen the very beginning of AI's own Cambrian explosion.